In this video, we're going to talk about the mean of a discrete random variable. So let's take a look at an example. So I record a quiz for my class. The scores are given. I want to determine what the mean score for the quiz is going to be. So obviously what I'll do is I would add up all the values and divide by the total number of students that took the quiz, which in this case is going to be 10. Add them up, divide by 10, you get 5. So now, I'm going to rearrange them from least to greatest. Then I'm going to group them together. So 0 plus 0 plus 0, that's nothing more than 0 times 3. I can write 5 plus 5 plus 5 is 5 times 3. 8 plus 8 is 8 times 2. Now, I'm going to separate these, so I'm going to do this, and I'll do this, and I'll do this, and this. So, I'm going to write this as 0 times the 3 over 10, plus, I'll take the 5 and multiply by 3 over 10, plus 8 times 2 over 10 plus 9 times 1/10 plus 10 times 1/10. So what does this give me? It's the 0 times what? The probability that you'll randomly select a 0 quiz plus 5 score times the probability of selecting a quiz score of 5 plus 8 times the probability you will select an 8. And I can do this for 9, and I can do this for 10. So this idea here is the mean of a discrete random variable. The value times the probability, and then add them all up. Okay, so the mean of a discrete random variable is given by the summation of x times the probability that that event is going to occur. So the mean of a discrete random variable can be thought of as the mean outcome of the probability of experiment if we repeated this experiment many times. So in other words, if I gave the same quiz many times, I would expect the average to be around a 5. Okay, so let's calculate the mean of the baseball example that we did earlier. So remember, I put all the probabilities on the side here. So how am I going to set this up? Well, the mean here is going to be what? 4 times the probability 4 will occur, plus 5 times the probability 5 will occur, plus 6 times the probability 6 will occur, plus 7 times the probability 7 will occur. So, probability of 2, that's 2/10. Probability to go 5 games is 0.175. Probability to go 6 is this. And the probability of 7 is 4/10. So, multiply. And now add all the decimals. That's going to be 5 and 825 thousandths games. So now I'm going to write the interpretation for this below. So on average, each World Series event plays about 5 and 825 thousandths games. Okay, so another way of saying the mean of a discrete random variable is what is called the expected value of a discrete random variable. And again, all that means is it's the mean of a discrete random variable. So the formula for the expected value is exactly the same as the mean. And the interpretation of this expected value is the same as the interpretation of the mean of a discrete random variable. Okay, let's take a look at an example. So according to Bristol Mutual Life Insurance's mortality table, the probability of a 20-year-old woman will survive 1 year is 0.994. If a 20-year-old woman buys a $10,000 1-year policy for $100, what is the expected value for the insurance company? Interpret the result, and who does this in favor, and justify. So when we write these expected value problems out, you want to be able to come up with all the different scenarios. So here are the two scenarios. The woman is alive after 1 year, and the insurance company doesn't have to pay out the $10,000. Or the woman dies during the year, and the insurance company has to pay out. All right, so the expected value, okay. So what is the profit for the insurance company if the woman survives? Well, that's going to be $100. And what is the probability that that person is going to survive? Well, that is given as 0.994. So the or statement tells me I'm going to add. Now, what is the company's profit? The problem is they've got to pay out the $10,000. So the $10,000, the woman still has to pay the $100, but the insurance company is going to have to pay out $9,900, meaning that the company is going to lose that. So it's going to be negative $9,900. Now, what is the probability that the woman is going to pass? Well, that's going to be the 1 minus the probability that the woman is still alive. That's going to be 0.006. Okay, so multiply. And multiply. Subtracting here, the expected value is $40. So let me write out the interpretation of what this means in the context of the problem now. So the company expects to profit $40 for each life insurance and policy sold. So that's not the total profit, that's per insurance policy sold. So if they sell 2 of them, it's 40 times 2, that's 80. If they sell 10, they would expect to profit 40 times 10, which is $400. So who benefits here? Well, clearly the insurance company benefits because their expected value, as we just figured out, is positive. So let me write that out now. So this favors the insurance company since their expected value is positive. Okay, let's take a look at the next example. So suppose you go to a sporting event and purchase 1 ticket for their 50-50 raffle for $10. 1 winning ticket pays $2,000, 2 winning tickets pay $10,000, and 5 winning tickets pay $100. All other tickets lose. Suppose there are a total of 10,000 tickets that were purchased. What is the expected value of this game for you if you buy 1 ticket? Interpret the result, who benefits, and what is the expected value for you buying 10 tickets? So let's write out in words what can happen in this scenario now. Well, you could win $2,000, or you can win $1,000, or you can win $100, or you lose your $10. Okay, so let's do the expected value. So if you win $2,000, don't forget you've still got to pay the $10. That's going to be a profit for you of $1,990. What is the probability that you will win? Well, there's only 1 winning ticket, so that's 1 out of a total of 10,000, or means to add. If you win 1,000, don't forget you still have to pay the $10, so your profit would be $990. And that is 2 winning tickets, so that's going to be 2 over 10,000. Or means to add, if you win 100, 100 minus 10 is $90 that you would profit. And there are 5 winning tickets, so that is going to be times 5 over 10,000. Plus, well, if you lose $10, that's minus 10. Well, how many losing tickets are there? Well, there's a total of 10,000. There are 1, 2, 5 winning tickets. So that's a total of 8 subtracted from 10,000. That's going to be 9,992 losing tickets out of 10,000. Okay, so multiply. Okay, so add these, that gets me this. which equals this. So it looks like every time you buy a ticket, you're going to lose on average $9.55. So let me write out the interpretation for this now. So on average, every time you buy a ticket, you will be expected to lose $9.55 per ticket bought. Okay, so who benefits from the raffle? Well, obviously the person buying the ticket has a negative expected value, so it means the person running this raffle is the person that benefits. So let me write that out now. So the person running the raffle benefits since the person buying the tickets to the raffle expected value is negative. So, what is the expected value of buying 10 tickets? Well, that's easy. So buying 10 tickets would be 10 times the expected value of 1, which is negative $9.55. That equals negative $95.50.